Hello, this is a video tutorial of the Big Ideas section 3.5, equations of parallel and perpendicular lines. For learning objectives in this section, you can use slope to partition directed line segments. You can identify parallel and perpendicular lines, and you can write equations of parallel and perpendicular lines along with using slope to find distance from a point to a line. So jumping in the first example right away, dealing with partitions of directed line segments. So find the coordinate P along the directed line segment so that the ratio is 3:2. So you're given two coordinate points, A and B, at 3:2 and 6:8. And there's some point P along this line that's going to create a ratio of 3:2 of these two line segments. So in order to divide that into the ratio of 3:2, you got to think of it as a partition of that line segment into 3 plus 2 from one side to the other, so that there are 5 total congruent pieces along this line segment. So point P is somewhere that is 3/5 of the way from point A to point B, which means that we can find a rise and run from point A to point B. And it's going to be much easier if we leave our slope in terms of a rise and run or a fraction, because it is 3/5. 3 could be our rise and 5 could be our run, and to not simplify. So remember that the slope formula is y2 minus y1 over x2 minus x1. And that's where that rise over run comes from. So the slope of line AB, we're going to take the difference of our y's, which is 8 minus 2, and divide that by the difference of our x's, which is 6 minus 3, to get a ratio of 6/3. Now remember, normally you would simplify this, but because we are looking for a ratio of 3/5, from A to B, we're going to leave it in terms of that rise over run. So the rise is 6, the run is 3. And to find the coordinates P, we're going to add 3/5 of the run to the x coordinate of our A point. And then we're going to add 3/5 of the rise to the y coordinate of our A. So this is what it's going to look like. Since our run is 3, we're going to take 3/5 of 3 because we want to go 3/5 of that run direction. And the word of just means multiply. So we're going to take 3/5 times 3, which is going to be 1.8. So our run of the partition is only 1.8. 3/5 of that whole run is 1.8. Doing the same thing with the rise, 3/5 of 6. Another word for of is multiply, so we're going to just take that fraction multiplied by 6, and we're going to get 3.6. So combining these two things together is going to give us the coordinate points of our P. The rise is going to represent the y coordinate plus our original point, and the run is going to represent our x coordinate plus the run. So 3 plus 1.8 for our new x coordinate, and 2 plus 3.6 for our new y coordinate is going to be 4.8 and 5.6. All right, slopes of parallel and perpendicular lines. So if you have two lines that are parallel on a coordinate plane, and they are both non-vertical, which means they're not straight up and down, they are parallel if and only if they have the same slope. Remember, our if and only if is a biconditional statement, so these definitions work both ways. If two lines have the same slope, then they are parallel. Same thing with our perpendicular lines. In a coordinate plane, if you have two non-vertical lines, they are perpendicular if and only if the product of their slopes is -1. So product just means multiply. But I think an easier way for you to remember if slopes of perpendicular lines is opposite and reciprocal. So if you imagine that blue line has a slope of a negative, this blue line right here, let's say it's looks like negative, I don't know, -3/2. The red line would be a positive slope. So that's the opposite, it means you change the sign. And the reciprocal would mean that you change the fraction. So if this blue line is -3/2, your red line would be 2/3. You just flip the fraction. What's on top now becomes on bottom, and vice versa. All right, so we got a bunch of lines. Determine which ones are parallel and which ones are perpendicular. So remember our slope formula, which is y2 minus y1 over x2 minus x1. We're going to need to do that with all of these lines. So let's focus on the blue line A first. We got the coordinates -3, 2, and 0, 3 plugged into our slope formula, and that gives us a slope of 1/3. Line B, we're using the coordinate points 0, -1, and 2, 0. So plugging that into our slope formula, we get 1/2. Line C, finding the slope, -1, -5, 1, -4. Plugging that in our formula, we get a slope of 1/2. And line D, the last one on here, coordinates -2, 0. And that other one, -3, 2, is an intersection from our point A. This point is also on the purple line. So that gives us -2. So first, the easiest thing to identify for parallel is just which ones have the exact same slope, while lines B and C are both 1/2, so those slopes are parallel. Then to find perpendicular, we're going to look and see if any are opposite and reciprocal. Taking the fraction 1/2 and flipping it is a 2, and then changing the sign is a negative. So line D is perpendicular to both lines B and C because they are opposite reciprocals. Or if you multiply them together, you get the number of -1. But I think it's just easier to look at it and think if you flip the fraction and change the sign, then that's perpendicular. So B and C are parallel, and D is perpendicular to both B and C. All right, writing an equation of a line that's passing through a specific point, and that is parallel, I can't see that because of my toolbar, parallel to the line y equals 2x minus 3. So first, in order to write a line, you need to find a slope. Two things you need to write an equation of a line are a point and a slope. We're given a point, so that's the easy part, but now we just have to find a slope. Remember, parallel lines have the exact same slope. So when we're looking at this y equals 2x minus 3, our new slope is going to be the same as our old slope. And this is written in y equals mx plus b form, where the m is the slope and the b is the y-intercept. So our m, which is just 2, is going to be the exact same slope of our new line. Okay, then we need to find our new y-intercept by using the slope m and our coordinate point -1, +1. So in our equation, y equals mx plus b, we're going to be plugging in y, m, and x, and leave the b blank, because that's what we're trying to find. So our y is a +1, our x is a -1, and an m is a 2. So we're going to plug those things in right there and leave our b the way it is. Simplify that down by multiplying. 2 times -1 gives us -2, and then adding that 2 over to the left gives us b equals 3. So we're going to write an equation of m equals 2 and b equals 3 in y equals mx plus b form to get y equals 2x plus 3. So that is an equation of a line going through the point -1, 1 and parallel to y equals 2x minus 3. Notice that they have the exact same slope. They're going through different points, and they will not intersect each other. Okay, what about perpendicular? So writing an equation of a line that's passing through the point 2, 3 that is perpendicular to the line 2x plus y equals 2. So this equation is written in standard form, which we're not completely given what the m is. We have to rearrange them into a different order to get y equals mx plus b, which means you just have to move the 2x over to the right, and you move that positive 2x by subtracting. So your slope here, or your m, is a -2. Now, in order to find perpendicular slopes, you need to find the opposite and reciprocal of -2. And the opposite is just changing it to a positive, and then flipping that fraction. 2 over 1 now becomes 1 over 2. Or the example here is showing what can be multiplied to get you a -1. Well, you multiply by 1 over 2. Either way works. So now using that m to find the y-intercept, or a b, with the coordinate point 2 over 3, we're going to plug these three numbers into y equals mx plus b, leaving the b blank. So y is 3, m is 1/2, x is 2. Plug those three things in these first three spaces right here. 1/2, 2, and 3. Multiplying 1/2 times 2 gives you 1, and then getting rid of that 1 over to the positive 3 would give you a 2. So your slope is 1/2. Your b is 2. Writing that in y equals mx plus b form gives you the equation y equals 1/2 x plus 2. And you can check that by graphing to make sure that those slopes are perpendicular. Looks like they create a 90-degree angle, and they're going through the coordinate point 2, 3. All right, finding the distance from a point 1, 0 through the line y equals -x plus 3. We're going to have to think back to chapter 1 and remember what the distance formula is, because we're going to end up using that here. So first we need to find an equation of a line that is perpendicular to the line y equals -x plus 3 that is going to pass through that point. Because in order to find the shortest distance from that point to that line, it's going to be perpendicular. So first, find the slope of the perpendicular line. We're given that our first slope is a -1. So the perpendicular slope of that would be a +1. Because anything times -1 to get -1 is just 1. So our new slope is +1. Then we're going to need to find the y-intercept using that slope and our other coordinate point 1, 0. So plug those three things in, get 1 and 0 and 1 to get a new y-intercept of -1. So the equation of the line that is going through 1, 0 and perpendicular to this line is y equals x minus 1. Okay, so that's just the equation of the line. Then we need to find the distance. So we're going to use those two equations to write and solve a system of equations to find a point where those two lines intersect, or where those two lines cross. So that y equals -x plus 3 is the equation that we were already given in the problem, and the y equals x minus 1 is the new one that we just found. So we're trying to find this coordinate point where the line is going to cross that other line, so that gives us 2 points to use for our distance formula, because we can't use just 1 point to find the distance. We need 2 points to find the distance. So moving on, in order for these two things to be solved, your y's are the same, so you can just set this -x minus 3 equal to the x minus 1 just by the transitive property of two equations being equal to each other. So plug that in, combine like terms, and you simplify down by getting rid of that 3, and then you get x equals 2. So then the only thing you have to do is pick one of your other equations to plug this 2 back into, and simplify it down. You can pick either equation since they're the same. If you do the first one, you plug in -2 plus 3 to get 1. Or if you do the second one, you plug in 2 minus 1 to get 1. It doesn't matter which one. But your x-coordinate is 2, and your y-coordinate is 1. So that is where those two lines intersect each other. So going back to the picture, This red line was the new equation that we found. The blue one is what we were given. This coordinate point 1, 0 is also what we were given, and that's where the two lines cross at the coordinate point 2, 1. So now the final step is to find the distance between 1, 0 and 2, 1. And that is using your distance formula that we talked about back in chapter 1, plugging that in, where you are subtracting your x's and squaring, subtracting your y's and squaring, adding those, and then square rooting those. So you should get the square root of 2, or if you simplify that down and round it to the nearest tenth, it is 1.4. So that's quite a lengthy problem, and it's broken down into multiple steps, and you are finding the distance between 2 points, where one of the points you had to find based on an equation.